Hiya and welcome to my channel. By the end of this video you will have learned how to complete the square of quadratic equations. Completing the square. This is a GCSE topic and questions can range from level 6 or 7 to level 8 or 9. So this video predominantly is for people taking the higher paper. So what actually does it mean to complete this square? Well, the best thing for us to do is probably look at an example. So here we complete the square of a quadratic equation, x squared plus 2x plus 5, and this becomes x squared plus 1 plus 4. So we'll look into how we can do this. Completing the square is a method of rewriting quadratics from one form into another format. But why might we want to complete the square? Well, the first reason is that it's another way of solving quadratic equations as an alternative to using the quadratic formula. Another reason is that we want to find minimum or maximum values of a graph or an equation. These are also called turning points. Now let's look at an example. So, x squared plus 2x plus 3. Let's ignore the constant term for now. So we'll just look at x squared plus 2x. Well, with this, what we can do is we can complete the square. If we look at x plus 1 all squared, that's going to give us something a bit similar to x squared plus 2x. The only thing with this is that we're going to get an extra constant term, which actually we don't need. Expanding these brackets here, we can use the smile method. Check out my Instagram if you want more examples of how to do this. Expanding these, we'll get x squared plus 2x plus 1. So the plus 1 is the constant term I was talking about before that we don't need. We can now replace x squared plus 2x with x plus 1 all squared, take away 1. Now here we need to also remember to add the 3 again. So we're left with x squared plus 1 all squared, take away 1, add 3, which is going to give us plus 2. In this next example, it's a bit trickier. The x squared coefficient is not equal to 1, therefore it makes it a little bit harder. This is more a level 8 or 9 question. To tackle this question, what we'll do is we'll factorise out the 7 in this instance. So we'll end up with 7 brackets x squared plus 4 over 7x, and then the 1 will just remain outside. The next step is to complete the square on what's inside the brackets. So again, we'll divide the x coefficient by 2 and that will become the constant within the bracket. Let's quickly expand this just to check what the constant is that we need to remove at the end. So we've got x plus 2 over 7 all squared, and that's going to give us x squared plus 4 over 7x, add 4 over 49, so we don't need that part at the end. So what we can do is we can replace the x squared plus 4 over 7x with x plus 2 over 7 all squared. Remember to take off the 4 over 49 and remember to take off the 1 also. As you can see here, the method that we've used is pretty much the same. We just needed to remember at the beginning to take out the x squared coefficient first. Now we're going to look at how we can actually use this new format of quadratic equation to find minimum or maximum values of this equation. What do we mean by minimum or maximum values of an equation? Well, these are just the biggest and the smallest numbers that the equation can take. If all the values in an equation are positive, then this means that the equation will never be negative. So let's look into this using an example. Here we start with x squared plus 6x plus 7, complete the square, and that's going to give us x plus 3 all squared, take away 9, which is the coefficient, plus 7. Now, looking at this, x plus 3 all squared is always going to be positive because all squared numbers are positive. So that means the minimum value is going to be negative 2. This minimum value is going to occur when x plus 3 is equal to 0. X plus 3 is equal to 0 means that x is equal to negative 3, so that's where the minimum value will occur. Let's look at another application, this time from an exam. Here we want to find out the exact solutions of 9 multiplied by x plus 3 all squared equal to 4. So they've given you the quadratic equation already in the format of completing the square, so you don't actually need to do that this time. First, we'll divide both sides of the equation by 9. Then we'll take the positive and negative square root of the right-hand side and we'll square root the left-hand side, meaning we're left with x plus 3 is equal to 4 over 9, or x plus 3 is equal to negative 4 over 9. In the initial equation, x was squared, and that's why you get two values of x here at the end. Looking at another exam question, here you're required to complete the square of the quadratic form, and then the second part is to solve the equation. This you will use the completed square format for it. X squared plus 4x, take away 16. Well, ignoring the take away 16 at the end, we can complete the square and get x plus 2 all squared. Let's not forget to take off the 4 at the end here, and then take off the 16 again. And that's going to give us the completed square format of x plus 2 all squared, take away 20. For the second part, we now need to solve this equation. Well, we'll use the completed square format to get the exact results. So x plus 2 all squared is equal to 20. Take the positive and negative square root of both sides and we'll get x plus 2 is equal to plus or minus root 20. You'll notice that this is going to give us answers of x which are not in a particularly nice form. In exams, I've noticed that the answers are not always nice numbers, so don't second guess yourself. Make sure you check your answer, and if it looks a bit horrible but you're happy with your workings, then stick with it. This is another exam question from 2018. Write 3x squared minus 12x plus 7 in the completed square format. Comment below if you managed to spot the error here. Taking 3 out as a factor, here we get 3 multiplied by x squared minus 4x plus 7 at the end. So dividing the x coefficient by 2, we'll get 3 multiplied by x minus 2 all squared, and then we just need to remember to take off the 12 at the end after multiplying back by 3. So that's going to give us 3 multiplied by x minus 2 all squared minus 12. Simplifying this, we've got our completed square format, and that's the end of the question. So you might still be wondering why you'd actually be asked to solve quadratic equations by completing the square, when you could just use the quadratic formula. Well, it turns out the quadratic formula is actually derived by completing the square of a generic quadratic equation, ax squared plus bx plus c. So, let's look at this now. Starting with ax squared plus bx plus c is equal to 0, we will then work to complete the square. First, let's divide everything by a. We will then take the c over a to the right-hand side and then complete the square on the left-hand side. We'll take off the constant minus b squared over 4a squared, and this is all equal to minus c over a. Now, adding b squared over 4a squared to both sides of the equation, we'll get all the constants on the right-hand side. Next, we're going to square root both sides of the equation, so we'll be left with x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over 4a squared. Now it's really starting to look like the quadratic formula, so we just need to rearrange the right-hand side. If we break up the square root, so we square root the numerator and the denominator, everything will all now be over 2a. And here we have it, the quadratic formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Don't worry about it too much though, you won't be expected to replicate this in an exam. If you fancy a challenge though, you could always try this. Thank you for listening. If you found this video useful, please like and share and subscribe to my channel. Comment below also if there's any topics that you want me to cover or any questions you want me to go through.